Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Dorma, part number C553D LRC 626. And the rest of the part number is the latch, the door thickness, the strike, 5001, and then I think there's probably some internal part of the part number in terms of how it's keyed. It's a long part number, but all hardware really is a long part number when you specify each particular component of a piece of equipment. The product catalog for the Dorma C500 series is only 8 pages long, but when you take into account the different functions, the different finishes, the different options in terms of how it can be keyed, the different options when it comes to the strike, the latch, you can end up with hundreds, thousands of derivatives. So this particular lock was supplied to a client like in a phase 2. Phase 1 was 800 doors. Phase 2 was 5 doors. So there's one additional keyed lock on the job that they required, and it's a C500. It's a C553, in fact. It's a 53 function, or an entrance function, and here it is. Okay, this video is going to go over the item, its components. We're going to talk about the template, the installation instructions, the product brochure, and my observations about the lock. First of all, this is my second Dorma video, and the first one was a bit more start-stop because it was the first time that I had encountered this grade 2 Dorma lock, and subsequently I've learned what I really appreciate about the lock, and obviously that will be incorporated into this video. I do believe that this is well above average in the range of grade 2 cylindrical locks, and it's for a particular feature that I'll show you in short order. So a visual tour first. This is the LR lever, the standard sort of lever trim that returns back to within 1/2 of an inch of the face of the door, completely handicap compliant. Nice spring return action on this. When I bring this down, it snaps back up. Even when I move it a little bit, it snaps up very positively. Small amount of movement, doesn't get stuck. That spring must be preloaded, I suppose, or however that would work inside of the spring cage inside of here. Works very nice. This is in the 626 finish, which is satin chrome. This video is going to talk about, and we're going to show how to remove that cylinder, how to put it back on. If you're going to service the cylinder by rekeying it, if you have to service the cylinder for some reason down the road. We're going to talk about if you had to maybe change the cylinder altogether, is why you would take that off. You'll need to take the inside lever off, and I've put it on for the purposes of just the initial part of this video to show you what the lock looks like complete. So here's our lock, okay? A through bolt, and actually this is optional. I would, of course, highly encourage you to use the lock installed with its through bolts, but they can be removed. And one minor thing that I like about this is it comes packaged, and not that they're the only lock that does, but it comes packaged to account for any way you want to put this lock together. It's got the screw pack in there, so let's take a look at the screw pack. Initially, I looked at this and said, there's far too many screws in there for this lock. I don't like it when there are too many screws, but then you realize, okay, there are different conditions of what could this lock, or how this lock could be supplied, which means you could have this type of latch or this type of strike, or you might install it with through bolts, or you might install it without through bolts. So they give you options by including all of the potential screws that you could come into. So you are going to be left over with screws, and that's, if you're not, you put screws in where they don't belong. So you'll have some screws left over. The latch bolt, this is a 2 3/4 latch. It has a 2 1/4 inch tall faceplate. It's 2 1/4, 1 1/8, typical for commercial installations. This is 2 3/4 back set. Nowhere on here does it measure 2 3/4, but you will see about 1 3/4 right to the center of the retracting portion. If you were to take half of the 2 1/8 inch hole that this lock would require, 1 3/4 plus 1 1/16, yeah, and now you start to see where 2 3/4 comes in, because that's the dimension from the edge of the door to the center of that prep, which would be 2 3/4, and in this case you have to have a 2 3/4 latch bolt. Okay. We have, in no particular order, the strike plate. This is a 4 7/8 strike. It's 4 7/8 tall, primarily seen in hollow metal frames, but you could have a wood frame prepped for a 4 7/8 strike. You know, generally a wood frame would not be prepped for such a large strike, but there's no reason that it can't be. And in particular, you might do a project where you have hollow metal frames and wood frames. Not uncommon, not unusual. The first type of application that comes to mind is you'll have a hospital. And the hospital has hollow metal frames, it has stainless steel frames, probably has fiberglass, but it'll have some wood frames. You might have a chapel, you might have a pastor or priest's office or a religious figure's office. That's going to be a wood frame. You'll see that very common. So in order to keep harmony between how everything is prepped, 4 7/8. So very typical. This 4 7/8 strike is about an inch and maybe 13/16 overall width. That's not the important part. The important part is the center line of the screw hole to the edge of the lip. That's 1.25 inches. And that's how strikes are measured, from the center line of the hole to the edge of the lip. You do need to be mindful of what lip length you're dealing with on your project, meaning you have to be mindful to make sure that when you ask for a strike, that you've confirmed, oh, that's perfect for what I need. And if you think about the different frames and doors and wall conditions and how all of those components work in conjunction with each other for that particular opening, the variable of lip length needs to be determined. Now, the 1.25 inches, 1 3/16, 1 5/16, that's the generic size that's going to work in almost all instances. That absolutely does not mean it's the best size. And to support that, the 4.5 inch by 4.5 inch hinge is the Swiss Army knife of hinge size. And right from the mouth of a very major manufacturer. You know why we make 4.5 by 4.5 inch hinges, meaning the width 4.5? Because that's what you distributors want. It's not the best option, and in fact, in many instances, it would not be the best option because that 4.5 inch hinge is just too wide. There's no need for the vertical axis of pivoting to be that far out of the center of the door. If you have a hollow metal frame that wraps the wall, okay, and you have no wall condition, 4.5 is too wide. The best practice would be a 4.5 by 4. So the point of the matter is, will 1.25 inch work? Sure, it'll work. Is it the best option? Maybe not. It might be. Maybe not. But the point is to scrutinize that. Determine, is this the right size that I need? When would you need to really think about it? A pair of hollow metal doors. There's a flat astragal welded to the face, the pull side of the active door. There's no slot in the astragal for the strike lip to penetrate through. Yeah, that's going to need to get cut off, or you're going to need to order the right strike. And the lip length on that, by the way, is 7/8. It's half of the door thickness. Generally, a door has an inset of about 3/32 of an inch from the face of the frame to where it's residing within the door rabbet. Well, what if that dimension was 1 inch? Okay. Or what if you were applying some sort of material to the face of the wall, and then you were going to apply something to the face of the door? Now you start to see, I have to think about this. Anyway, 1.25 inches is probably going to work just sweetly for you. And in almost all instances, you don't really need to give it thought, but you should always be mindful. Oh, is that correct? Or even better, can that size be better for the application? You know, realistically, these frames are wrapping the walls. They don't need to have such a long lip length, and they can certainly get away with one smaller. So be mindful of that. So this is a keyed lock. It's an entrance function. We're going to go over that. This is a Dorma bow. This is a 6-pin Schlage C keyway. Okay. Yeah, it definitely is. Which is a standard keyway for Dorma. It's a standard keyway for many manufacturers because of the ever-present nature of the Schlage C Classic keyway, along with the Kwikset 1176. That's engraved AA51 in standard key coding system nomenclature. That would mean that it's the 151st change key under the A master. Pardon me. That would mean that it's the 151st change key under the AA master, under the A grandmaster. Now, this project is actually a level 2 system, and I mistakenly told them it's AA 151 because it is the 151st change. Because it's a level 2 system, that ought to say 151 AA. It's a level 3 system when you put the letters in front of the numbers. That doesn't really matter at all. For all intents and purposes, this could be a level 3 system. It just happens to not be. So the Phase 1 project that we did about a year ago had 150 keyed locks, and it had maybe 650 or whatever it was passage sets. And these other boxes here are more passage sets for the project. The factory was able to refer to their keying documentation and to basically assign me the next change under the master. And that's what was done. And what's really nice, to take a small diversion into the keying that Dorma did, what I reviewed the bidding list that they did on the primary project of 150 keyed locks, they wrote that in the rotating constant method versus total position progression. And I was enheartened to see that they would use the rotating constant method because I think it's just simply far less common, and I think from distributorship like myself at this level, manufacturers, wholesalers, distributors, and end users, or contractors, however it is, the rotating constant method isn't either ever heard of or not understood whatsoever, or total position progression is all I need. Or they might be using a shoebox method to key locks. But I was enheartened that they wrote it in the rotating constant method because that system for a level 2 is simply superior in every regard to total position progression. Integrity of the cylinder, security of the cylinder, how much additional pins and then therefore incidental keys that will be potential to run through the cylinder. It's a little harder to grasp initially, but it just really takes committing yourself to reading that chapter twice. Now if you want to go on further and talk about how both of those keying systems can then be expanded to handle quite complex systems, which it's never really complex. Each system, but especially total position progression, because I think it's just easier to understand when you have more than 2 levels of keying. The systems are capable of handling extreme cases, and I was enheartened again that they wrote it in rotating constant, because I said to myself, that's advocating on behalf of the end user who doesn't know anything about how pin tumbler cylinders are keyed, doesn't want to know, blissfully ignorant as to how the mechanics of a cylinder actually work, and they could have pinned this another way. And I didn't pin the material here because in instances like this, it's less expensive to have the factory do it and then to ship it to the job. 150 locks to come to me to reship to Texas didn't make sense for me to do that. So it was a great job that they did that in rotating constant. Several, I don't know about several, but there are certainly books available. Don O'Shell, if I'm pronouncing his name right, late Don's name right, John Trumpy, Jerome Andrews, are people that I own books that have been written on Master Keying, Standard, Intro, Advanced, and they discuss at length these systems. So Schlage keyway, 6-pin, that's what it is, stamped with a 6. This lock is also going to include installation instructions and a template. Okay, some basic dimensional properties, I suppose, and I will admit the only thing that I'm unsure about this lock is the base material of the lever. They say it's cast. That's all they say. They don't say it's cast brass. They don't say it's cast zinc. My absolute feeling on it is that it is cast zinc. But they use the BHMA code for this. They call this 626. And if you understand BHMA, the Builders Hardware Manufacturers Association code, you could call this US 26D. That means satin chrome. It doesn't tell you the base material. We convert that to BHMA into a 3-digit code. US 26D can be 652 or 626. 652 means a steel base. 626 means brass base. They're using 626 for this code. So if the code is applied correctly, this is made of brass, but this is an imported grade 2 cylindrical lever lock. I don't see this lever being made of solid brass or cast brass. We're going to find out. I've got a memo into the manufacturer. Overall length of the lever, just to put the tape measure around, looks like it's about 4 3/4. Diameter of the rose, let's take a look at that. Just kind of gauge that on the camera. Looks like it's about 3 1/4 or so. Okay. Projection of the trim from what would be the face of the door looks like it's about 2 1/2. All right, so what I think we'll do now is let's switch to the screen view, and we're going to take a look probably at the installation instructions first. That's the bulk of everything that we need to discuss about this lock. Okay, so here is the item that we are currently looking at. And what's nice about this is there's just 2 pages. Because it's a keyed lock, we will need to look at page 2 because they talk about removing and reassembling standard cylinder changes. Again, if you were to need to remove that, how to go about doing it. Very simple and straightforward. The installation instructions thankfully begin with a overall exploded view. And, you know, if you have, you know, memory of the first 10 minutes of this video, we will quickly go through part 7, obviously the business end of this, the lock assembly, okay? Your lever and your cylinder are already installed. You have your latch bolt, part 11. You won't have part 9 because part 9 allows you to use a 1-inch wide latch bolt where the door is prepped for 1 1/8, so that latch filler is not included. They probably would include it if you ordered a 1-inch wide faceplate, but however, best practice would require you to actually determine that part number and then to include it into that epically long part number here. So by LRC, by 626, by 15252, by 134, by 5001. And when it comes to the latch bolt portion, yeah, you would need to include that. Otherwise, if it's not considered standard or published as standard to be included, yeah, you'd be remiss in omitting that. So part 8, the latch sleeve, you would omit that if your door was prepped for a 7/8 hole, maybe 15/16 is where you would omit that. You could pull that off without trouble. Part 12, you didn't see the mounting plate because it's underneath the spring cage, which is part 14. The scalp plate or rose, it's not a scalp plate, it's just a rose. That's certainly brass. And that's, anyway, I was going to say, the finish on the lever and the finish on the rose are very, 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 very similar. As in, I can't tell the difference, leading me to believe that might be brass. Inside rose, your inside lever. You're going to have a screw pack, and there's a ton of screws in here, and we're going to go over those. They do allude to the installation process. There are 4 longer screws. There are 2 stubby screws, short, fat ones, that are part 19 that are probably not shown. They might be shown over here. Yeah, they're shown over here. So the difference between these 2 drawings is this has the through bolts, this does not. So if you're doing a through bolt installation, which is preferred and certainly recommended, this is what it needs to look like. If you're doing non-through bolt, that's what it needs to look like. You'll use those stubby screws if you're not doing a through bolt. So the first thing to do is to install the latch. The purpose of going through this is when you open the box to determine that you have everything you need, that everything is there before you start the job, that nothing's been missed. The latch is the first thing to be installed, assuming that the door is already prepped. That's what you're going to do very first. Let's jump to the template. This is a 2-page document. Page 1 is a wood door, what a wood door prep is going to look like, and then a steel door, or a hollow metal door prep is going to look like. And the edge of the door to the center of the hole, that's the back set in this case. Edge of the door to the center of the hole is back set. This lock is 2 3/4. There are only 2 latch bolt lengths available in this lock, 2 3/8 and 2 3/4. At least I'm practically positive of that. Let's confirm. Right, yeah, 2 3/8 and 2 3/4 only. No 3 3/4, no 5-inch. So you need to, if you're going to prep the hole, you need to be mindful of what latch bolt length you have. If you're not sure, attach the latch bolt to the chassis and then measure the edge of the latch bolt to the center of the chassis. And then you'll know if it's 2 3/8 or 2 3/4. 2 3/8 is like, well, is it like 2.5 inch or maybe just less, or is it quite clearly greater than that, is kind of the way I explain it to clients. If it's 2.5 inch or a little bit less, then it's 2 3/8. If it's quite obviously it can't be 2.5 inch and is way beyond that, then yeah, it's 2 3/4. What you'll notice here is that there is a square edge door, or they call a flat edge, and then a beveled edge door here. The purpose of that being important, and why do they show it two different ways, is because the term backset is indeed the edge of the door to the center of the hole, but the edge of the door is referenced from the center of the thickness of the door, not from an outside edge. So that, defining backset that way allows us to not be concerned about the bevel. This bevel is what's called 1/8 in 2. For every 2 inches in door thickness, there will be the difference from this point to this point of 1/8 of an inch. So this is 1 3/4, most certainly. So that dimension is going to be ever so slightly less than 1 1/8. But that's really important, so that if you were to drill the door and it's beveled, be mindful. You need to compensate. If you're measuring from the pull side or the push side, you'll need to be about a 1/16 of an inch heavy here, and then about a 1/16 of an inch light on here, so that that hole is right in line. Can you be a little tiny amount off? Can you be a 30-second off? You can. The lock's going to tolerate that. You get into 1/8 of an inch off, and you're going to start to say, well, that doesn't work so well. So be mindful to get that correct. Why point it out? Well, not a big deal on a lock. You can kind of ovalize that lock hole, but if you drill a door viewer where there's very little margin on a door viewer, you're going to want to really understand. I remember the first time, not clearly, but I remember the time that I had prepped a hole in a door, and I couldn't figure out, why am I off this, like, just a little bit more than a 1/16 of an inch, and I just couldn't figure it out. And the more I studied the problem, I realized that it was my point of reference. I was going 2 3/4 from the high side and the low side. So my drill, everything worked out fine because it was a lock. But once I realized why it was that way, I was able to correct the way in which I proceeded. This lock will allow you to, and it's again preferred, to drill holes at 12 6. That's a 5/16 hole. 1 3/8 from the center line in either direction. On the backset center line as well. Very much recommended. If you're doing a hollow metal door, this is just a drawing that shows it on a hollow metal door. Okay? No inherent difference. You're probably not going to be drilling and grinding and welding any of this together, to prep a hollow metal door. But nonetheless, if you are ordering steel doors from your manufacturer for these locks and they ask you for a template, there's your template. That's what you're going to send to the factory and say, this is what I need. This is the document. And actually, more commonly to your wood door manufacturer, they may insist on you providing a template. Depends on the manufacturer. Some people, there's a minority of manufacturers that will tolerate you just sending plain language orders to them and telling them in industry standard language what you want. This would be a modified 161 for Schlage. MOD 161 for Schlage is what I would call this. And they would understand it's a 161 prep with lever through holes for a Schlage. You could also say for a Dorma, but then they're going to say, well, send me a template. You say Schlage, everyone knows that one. But they might require that you fill out machining sheets and then with supporting templates, and this would be that document. That's why that's important. So getting the latch installed, it's important to know that this template shows an 1 1/8 wide. You can do this in a 1 inch wide as well, so be mindful of that. Okay, don't just do an 1 1/8 prep, or you will certainly end up needing that latch face filler, which is again meant to convert if you have a 1 1/8 wide preparation but only a 1 inch wide latch bolt. First thing to do is to get that latch installed. However you need, be sure to pre-drill the holes. You don't want to split the edge of that fire-rated wood door if that's what you're doing. We'll talk about that again in a moment. When you put the latch into the door in step 2, the absolute most important thing here is that you get engagement of the latch exactly as it's shown. This retractor is a T, well, here it looks like a letter H. Okay, this is the retracting hub, this area in white here. Okay, these little tangs project out of the latch bolt itself and need to engage the underside of the exterior portion of the chassis. You have to be mechanically engaged like this, shown more clearly here, in order for the latch to properly work, to reliably be withdrawn when you rotate the trim. Okay, now it's hard to install it otherwise, but I've had people call and I've seen it. Hey, I rotate the lever and the latch doesn't come back, or I put the lock together, I close the door and I rotate the lever, now I can't get in. The latch is not moving. Wow, well, that's no good, because it's clear they somehow installed it without it being connected together at all. So that's what you're looking for. Now, step 2 also brings me to the primary reason that I like this lock the most compared to its competition in a grade 2 imported, well, any grade 2, in fact, regardless of what country of manufacturer, which is Taiwan for this lock, if I'm not mistaken. And that, getting to that point, we start by reviewing how to adjust the lock for door thickness. Now, this is going to come from the factory. Lock comes adjusted for 1 3/4 from door factory. So you're probably not going to need to discover the real magic of this lock, but we're going to demonstrate how you would adjust for door thickness and therefore show you why I most like it. And let's switch back to the camera view now and take a look. Now, before we talk about adjusting door thickness and discovering what I love so much about it, I had mentioned a fire-rated door, not splitting the holes if you pre-drill when you pre-drill for the screws. That is stamped UL. Okay, so this is on the latch bolt, there is indication of the UL listing and the capital letter F. So the letter F can be expressed as a lowercase and an uppercase, obviously. In the door hardware industry, the lower and uppercase letters F mean two different things. In a uppercase F, that means that this has been tested to positive pressure, the modern way by which a door is tested in terms of the plane of where the most impact a actual fire has on the door and frame and its hardware, rather than the lowercase f, which would indicate a neutral pressure test standard was conducted. So that's what the uppercase F means, and you're going to see that all over. If you look at older latch bolts, and Schlage comes to mind because I've seen it countless times, you'll see a lowercase f. Now, it's okay to use that, provided that your requirements permit a neutral pressure tested door assembly. But positive pressure, while I'm not an expert on the subject, I would think that supplying positive pressure tested hardware and a neutral pressure minimum requirement would not be a problem at all. But the point is, your hardware has to be not only tested, which if it's successful, it's therefore listed. It's on file at the testing laboratory. If an inspector were to call up that testing laboratory and say, hey, is that Dorma so-and-so, blah, 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 this and that, is that approved for use on fire doors? Because maybe they didn't see that. They could refer to that listing and say, yep, you're all good. But almost all hardware, as a result of being tested, listed, must be labeled. Lock sets need to be labeled, and that's what that actual stamping is. The only thing that doesn't have to be labeled would be your hinge, provided it is a steel base or stainless steel base ball bearing hinge. You don't have to have a stamp on there if it is a standard ball bearing hinge. If it is a spring hinge, it must be stamped. So the only piece of hardware is just your regular non-self-closing full mortise ball bearing, whatever that construction would be. Must be steel based or stainless steel. Cannot be brass or bronze or any other material. Now, why do I like this lock? Let's talk about it now. In order to do that, we have to remove the cylinder. In order to adjust its door thickness, we have to pull the outside trim off. So let's dive into that now. The screw package has the pin release tool, which is this round little gizmo here, and we're going to have to get into this screw pack, so I'm just going to pull that off, pull all that material out now. And we're going to go over these screws as we assemble the lock. So our little lever release tool. One of the keys, and it would be good for you to refer to page 2, step 4, removing and reassembling standard cylindrical cylinder lever. If you have to change the cylinder or adjust its door thickness, you'll have to do that. Key is good. This process is almost the same for all locks. Key goes in. You're going to need to rotate that clockwise, basically all the way, which in this case is about 90 degrees. So I need to rotate that key. I need to rotate that key, and once I rotate the key, and I'm just holding the key rotated, you'll insert your pin tool down in here, and with the key turned, you can depress then the spring-loaded tab that's in there. And as I was pushing, I was using the, not sure what that part of your hand is called, the web of your hand, to push that lever up, where I could feel that it became disengaged. So I've got the outside trim off, and while I have the outside trim off, that's the key's normal position. Okay, just you'll notice. So what I'm answering here is, why do you need a key to remove the outside trim? In almost all locks, you need the key. Now there are some actually that you don't. So that tail piece is horizontal. Okay, when I turn that key 90 degrees, that tail piece is now vertical. Okay. Sorry. Horizontal, vertical. Horizontal, vertical. Why does that matter? Why is that the magic touch? So you're going to see inside of there a slot. That's where the tail piece goes. It's horizontal. Okay. Now, when I push my pin tool, I'm pushing on this little spring-loaded gizmo here. This C-clip that's spring-loaded. And I can push on it with my finger, and you can see that it'll move. So now imagine this. The lever is on the lock. The tail piece is inside that slotted hole. If I push on the pin, it won't move because that little doodad that's right there at the tip that you can see move is going to be blocked by the presence of the tail piece. But when I put that key in and I turn it 90 degrees, now all of a sudden with that little doodad that's coming out, I can't do this. But when I rotate 90, now I've got enough room for that C-clip to be depressed to pull the trim off. That's why it works that way. Okay, so in order to adjust the door thickness, you'll take the outside rose off. It's just simply going to come off. It just will pull off. There'll be no reason for you to remove that rose from the outside. Now, you'll then take this plate and rotate the plate. It's threaded. You can rotate that plate to any size that you want. And the reason that you will is because you need to accomplish 1 3/4 inch, you need to center the retracting hub in the center of the door thickness, okay? So you'll rotate this plate in order to accomplish that. Now, what I like most about this lock are these two little protrusions here, and they happen to be tapped on the inside as well. After you've adjusted it, and if it's 1 3/4 inch thick door, don't do anything. It's no need to adjust it. That's going to go back on. Okay, and these two protrusions are going to go through our mounting plate. And then as I push it forward, they literally go into the hub itself. Sorry, excuse me. They will literally go through the chassis itself, all the way through. So the reason I like that is the outside spring cage is, with the through bolts, connected to the mounting plate on the outside. Okay? Which is also connected through the inside spring cage. So this spring cage underneath the rose is connected via screws to the chassis, to the outside spring cage assembly, and all of that is engaged into the chassis because of those projecting feature to the outside mounting assembly. Okay? So talk about all of it being belt and suspenders connected together. The point of all of that is the chassis itself is ultimately connected mechanically to the lever through bolts that are through bolted through the door, which is why it's so crucial to have those installed, because without those you really don't have the same capability of the lock to over time resist, as you rotate the lever trim, that chassis from getting from basically being able to hold your latch, and then it's going like this. And sometimes people will call and say, yeah, the latch came disconnected from the lock. And I've gone to the job, and well, yeah, because the lock's like this. And basically the chassis is now pointed at an angle, and the latch bolt has stayed straight when it needs to be this way. So the latch basically popped out of the chassis and the retracting hub. So that's why I like this lock a lot. And in fact, discovering that feature allowed me to... I reflected on the fact that the client has 800 of these locks. They've been installed for almost a year. Not a single problem with any of them. Not at all. Not one. And that's really great. You know, that's really great. And I would absolutely attest that to that feature. I have not seen that from other folks. Maybe I just haven't reviewed your lock yet. So, okay, that's what I like about this. Now, since we have this off, we're going to go to step 4. If I needed to service this cylinder, super simple and easy. They even have it marked. That's nice to be able to do, because I've gone to... I did a large project at... very, very close to, like across the street from the Field Museum in Chicago on Michigan Avenue. Not across the street, but you've got Michigan Avenue, and then you've got the Field Museum in Soldier Field. A building that was owned by Standard Oil that was turned into a condo conversion in the very late 1990s. 98, 99, I forget. There were hundreds of mortise locks. And I keyed all of those locks, and they were mortise locks, so they were mortise cylinders. So what I did was, it all had to be master keyed. So I had to pull the cam off, and I stamped the back of the cylinder so that unless you removed the cylinder and then put the key in and turned it 180 degree, you wouldn't see the stamping. And I had the client call and say, yeah, your key doesn't work in unit 905, or let's just say unit 910, if you follow my meaning, unit 910. And I says, okay, that's possible. But, I mean, I'm thinking in my head, I keyed these locks myself. I double-checked them. And I had him remove the cylinder. Okay, what do you want me to do now? Come on, I've got to get back to work. I'm like, okay, put the key in. Okay, turn it. Boom. Does that say 910? No, it doesn't. Okay, you got the cylinder in the wrong door. That's why. Because he went up with unit 910's keys, and they didn't work the cylinder. Well, it was for 90 whatever it was, or 1215 or whatever it was. So it's nice to be able to have that on there. And magic marker is all that they did on here, and the reason is there's no good place, there is no place at all to actually physically stamp on the cylinder. This area up here, the area above the circular portion, is called the Bible. That's what it's called. It's the Bible. You can't stamp on that because, other than the fact that there's a stamp on it, you can't really stamp a lot of information on there at all because that wall thickness is very thin, and you have to be mindful of that. So can they stamp it? Well, they obviously can. They have the manufacturer's stamp, whoever made that shell, that part number. But writing it in magic marker is not a bad idea because you eliminate the possibility of crushing this very thin material. You can't really stamp it on this curved side at all, naturally. Okay, not much real estate elsewhere, so writing it by hand would be good. So let's say that you had to service this. You're going to rekey it. Now, what's important when you're rekeying a lock like this is that you'll notice the tailpiece has this small little pin right at the tip of my finger. That's what holds that in. There's another preparation for the pin here because you can install the tailpiece vertically or horizontally. If you've ever worked on a knob lock, you know that the tailpiece goes in horizontally. And when levers first came out, like big time in 1992, meaning they were out, but customers weren't asking for levers because those cost more. But when ADA happened, it went from Monday night knobs to Tuesday morning levers. And I remember the first time I keyed a lever for a client, and I'm futzing with it, I says, that just doesn't work right. And I put the lock back together the way I'm accustomed to doing it. Well, I had put the tailpiece horizontally, like you do with a knob lock. Well, you'll notice that that's vertical. The problem is that it's not vertical, it's really horizontal, because how does a cylinder fit inside of a lever? It sits on its side, therefore horizontal. And once I discovered, with levers it's got to be vertical. Anyway, the point is, if you service this, put it back vertical, because you can put it back horizontal, because this same cylinder will be able to fit into a knob, is the bottom line. So this little gizmo here, this piece of black plastic called the lever insert, you need to have this. You need to have it because it'll help keep the cylinder in place. And also, if you're doing a fire-rated installation, you need to have it because, did you know that if you had a door closer on a fire-rated door and it was missing its plastic cover, is that door fire-rated? The answer is no. What does a plastic cover have to do with anything? In the first 3 minutes of a fire test, when that temperature hits 1800 degrees and parks there for the next 2 hours and 57 minutes, that plastic cover is gone, I would imagine. The installation instructions call that you install that, and indeed the lever insert is there. You can install this without the lever insert, and it may work, or it may not. I've not tried it. But the point of the matter is that needs to go in. And if it doesn't, then A, your lock may not work, and B, you will not have a fire-rated unit. That just holds, it stops the Bible from permitting the cylinder to shim too much. Now, if I push on it further, it's going to pop out, and that's how you take that out. So to reinsert this, basically, your assembly is just going to go on, tailpiece is horizontal. And what I just did was I touched the key, and that basically moved the cylinder to allow it to kind of fall into its hole. And at that point, I'll turn the key 90 degrees, and then I'll just push, because that turning of the 90 degrees allows that clip to move where it needs to move. And you did hear it click, but my key's not returning to 0, which tells me it's not fully seated. So when I pushed on it a little bit more and gave it a little bit of the Killer Kowalski razzmatazz, it's seated right where it needs to go. Okay. You always want to make sure that the trim is on. Literally pull on it. You want to be sure that you can see the head of the tab there as well. You don't want that coming off. So that does cover step 4, as we were discovering why I like the lock so much, which was step 2. Let's switch back to the screen view and continue with the installation instructions. Okay, so step 2, we talked about adjusting door thickness as a way to demonstrate how that lock is mechanically engaged. And I'll tell you, I don't recall in the product brochure seeing any mention of that, but boy, that would be my page 2 of my product brochure, because that really is the secret in the chili, so to speak. Now, installing the lock further, you've got the latch installed, you've got the lock chassis or the lock assembly engaged in the latch. Now it's time to bring the mounting plate. And this is where you need to determine, are you doing through bolt or non-through bolt? You can remove the through bolt studs from the lock by simply putting a wrench on them and turning them counterclockwise. They'll unthread. But installing the lock now is going to be a matter of attaching the mounting plate via these 2 screws into that hole and that hole, and then bringing the inside the inside spring assembly on top of that, and the other 2 screws through that hole and through this hole and into the through bolts that are here. So you're screwing the plate to the chassis. You're then screwing the spring assembly through the mounting plate into the through bolts. Belt and suspenders. I don't like that about some locks, because it's less elegant. But what's really awesome about these 2 screws, and why I don't like it from other locks, is, okay, it's mounted to the chassis. I can still rotate everything. They actually get threaded into the back of those projections of whatever that we're calling this. Stabilizer, whatever it is. Right in here is where you see it. They actually get threaded into that. So super locked together. Just locked together. Every component that can rotate is one unit once it's screwed together. I think what we'll do is look at step 4. Inside rose is on. You put the rose on, you snap your lever on. Let's switch back to the camera view and just demonstrate the final steps of assembling the lock on the door. Now I've got the lock put together, and I'm going to remove the inside trim in order to complete the installation. Your pin tool, your pin release tool, goes in. Kind of just push up on the lever as best you can without dropping anything or hurting yourself. Oh. Okay. So sometimes what happens is you push on the retaining clip, you can get your pin pushed in so far that it now becomes an obstruction to you being able to pull the trim off. So sometimes you have to back that off and then pull on that. So the lever will come off. Your inside spring cage with the rose, which is already attached, you don't need to separate it and remove it at all. It's not necessary for this. Oh, no, forgive me. We're doing the inside. Yes, you need to take this off. I'm quite sure this is stainless steel, in my opinion. I don't believe this is brass. That looks like it's stainless. Anyway, so this will come off. When you reinstall it, you'll see that there are these small little ridges here in this chase that you can get that installed onto via that small dimple that's at the tip of my finger here and here. That will go on. And then you can turn that clockwise and it will then click, click, and it'll stay on, is how that works. You can easily pull that off. Okay. Now we have our mounting plate. Okay. We're going to need these 2 inner holes and these 2 outer holes. Let's go over the screws first. You're going to have 4 of these long machine screws. You're going to use all of those if you're doing the through bolt installation. All 4 of these you'll use. You're going to have 2 stubby screws, and the 2 stubby screws will be used if you're doing a non-through bolt, and they're shown in step 3. This will allow you to lock the spring cage to the mounting plate here at the top hole at 12 and the bottom, the outer hole at 6, because that's tapped. Okay, I wouldn't do non-through bolt. You're going to have 2 screws for your 4 7/8 strike. You're going to have 2 screws for your latch bolt. The only other screws that are going to be left over, and you're going to have four left over, will be 2 more 832 combination screws for the latch. If you were doing a full lip strike or a T-strike, you would need these screws, which in that case you would be left over with the 1224 for your strike. So you're in this application, we're going to have 2 of these screws, 832 combo, and those 2 metric stubby little screws that are there left over. So the mounting plate is going to go on, okay? 2 of my long machine screws are going to go through this hole and then into the tapped hole in the back of the post that's engaging the chassis. Those 2 are going to go in. Then, imagine that those screws are still in. I'm just going to remove it for sake of demonstration. You're then going to bring your inside spring cage in. That hole is going to go through that outer hole in the chassis here and into your through bolt. Okay, let's demonstrate that. So we've got those 2 screws installed here, and then the other 2 long screws will go into through this hole here, top and bottom, through the mounting plate, and then into the through bolts. Okay. At that point, once you have all those screws attached, your rose will come. Your little dimple is going to go through the chase that I mentioned earlier, whatever that's called. You'll snap it, rotate it, it's all good. Lever will come on. And again, make sure that it seats correctly. I mean, all I'm doing is pushing, but it will, that's how you put these on. You're going to want to make sure that it's on. Lock the lock, make sure it works. Make sure the function of the lock works. Make sure everything works. It's great. In terms of make sure it all works, it's great. When you're installing this stuff, it's not considered appropriate to use a power tool. Have I done it? Yes, of course. Is it wrong to do it? Yes, of course it is. I will use a power tool to do the hard work of just moving the screw, and then I want to do the rest by hand because that's when you can determine you're too tight, you're too loose. Your experience will tell you when it's too tight or too loose. The point is, it's very easy with a power gun to really run those screws. Why doesn't my lever work real smoothly? Why doesn't it snap up to being horizontal? Yeah, are the screws too tight? Always be mindful of how tight the screws are. Too tight, the lock's not going to work right. Too loose, it's going to come off. If I made a living as a door installer, I would be dabbing thread lock on many things that I did, especially lock screws, because I want the screw to stay there. A lock, like a hinge, like an exit device, like a closer, is like the engine in a car. These are things that need maintenance. They're not going to last forever. Nothing does, really. But with maintenance, it can last a long, long time. I stayed at a bed and breakfast in Galena, Illinois, maybe 5 or 7 years ago, which is always a fun scenario. And basically the proprietor said, I had remarked this home was definitely antebellum era of the United States, and I had made a comment about the hinges because, being a hardware person, these were like 10-inch wide throw hinges, and I could tell that they were original, but they looked like they had been reworked or somehow. And the comment was, "Yeah, you only replace when you can no longer repair or rebuild." Improper maintenance is what allows things to last. So the point of the matter is, you know, that hinge was still there because they rebuilt it. I'm assuming that they had proper maintenance because it wouldn't be there 170 years otherwise. So we've talked about installing the entire lock. On page 2 of the installation instructions is where it will get into showing you the different functions, the 70 function, the 80 function, and they don't mention a 50 or 53 function. Classroom, storeroom, office, or entrance. An entrance function like this is a triple function lock. That's the way it was described to me by my father, and he's right. It is a triple function lock, and I had somebody say that to me the other day. This can act as a passage. It's always unlocked at all times. That's a 10 function. We're using Schlage numbers now, and Dorma obviously adopted those, a 10 function. When you push that button, the outside is locked. As soon as you rotate the inside, the outside is now unlocked. That's an office function. That's function 2. If I push it and turn it, the inside is always unlocked. The outside is always locked. That's a storeroom function. What's interesting about this is, we don't have to use the latch. Well, that might work. We need to remove the inside trim to test the nature of this function. So as I install the latch, okay, got the latch installed, unlocked. Now I'm locked on the outside because I pushed the button. When I push that latch bolt in, it does not unlock. Okay, so be mindful of that, which is not unusual. There are retaining and non-retaining versions of this material. I've had people order locks like this for bathrooms, and I says, well, that's probably not the best option. Yeah, I want to leave it unlocked. Well, with a triple function lock, you could have one person in the bathroom complete their business, rotate the lever, push the button in, and then pull the door closed, and now you're locked. So sometimes being mindful of how that works is why I point that out. On page 2, it talks about a classroom function. The key on a classroom lock needs to go in and turn 360 degrees in each direction. And that will turn it from always locked, a storeroom, to a passage, always unlocked. And you have key control over that. That tail piece needs to be timed correctly. You need to be able to go, and my arm can't go 360 degrees naturally, but if it's timed incorrectly, it will only go 180 in each direction. That's not the way that these work. And they'll talk, and if I had the classroom function here, I would be demonstrating it, but that's how those work. It's the timing of the lock. There's dummy installation. I won't review that. That's simple and straightforward. If you are doing interchangeable core in step 3, section 3 of page 2, I don't know why you would remove the trim at all. I don't, with small format interchangeable, with interchangeable core, I don't know why you would remove the trim. That's the whole point of interchangeable core, not removing the trim. If you had to service it, obviously you'd have to remove that, you know, something you needed to get in there, replace the lever. Okay, so we've covered the installation instructions. If there are any questions on any of that, please do feel free to reach out to me. Let's switch back to the screen view and get to the product catalog. Okay, so the product catalog is here as well, and this 8-page document allows us to review the overview of the series of locks. And it's nice that it's only an 8-page document. It's just a grade 2 lever, but that tells me that it's concise, that it's complete. There's not a lot of additional information. And we will glance over that and call out the important parts as we go through. Important parts. 1/2-inch latch throw. That strikes me as important. If you were doing a project where you needed to, and I've done a little bit of research already, if you were doing a project with fire doors, if you look at this label, I've had countless people call me up and read to me what labels say, which of course is part of the important part of the job. Listed 20-minute fire door. It was rated without hose stream. That's just the way the test was conducted. Because a 20-minute door, you know, may not require a hose stream test. What hose stream is believe it or not, if you're testing a door or hardware, you're going to let that bake for 3 hours at about 1800 degrees. Immediately at the end of 3 hours, they put a fire hose on it, and your lock still has to survive, or your door still has to survive. So it says here, min latch bolt throw 1/2 inch for single, 3/4 inch for pairs. Okay, min latch throw 1/2 inch for single, 3/4 for pairs. What they're telling you right here, 1/2 inch latch throw. What that should ring a bell in your head that says, whoa, I have pairs of doors that are fire rated. The Dorma Grade 2 C500 is not a contender because they don't have a 3/4 inch latch throw, which means that the projection of the latch bolt is insufficient. How much it projects off is insufficient. I've had customers look for locks. Oh, I need a 3/4. Oh, I've got a, they've got like a $50 lock. Yeah, I need to order a 3/4 latch for that $50 lock. No, I'm sure that you do, but it's not made. And then it turns out that you've got 15 of these openings, and now you're stuck at looking at a very different priced lock. So be mindful right ahead of the time that, you know, if you're doing a pair of doors that you might require 3/4 inch latch projection. Dorma makes those, just not in a C500 series. 3 lever designs, LR, LC, LG. We're doing the LR, the most common style of lever. Now this is an LRC because we've got a C rose, but they don't really refer to it as a C rose in this catalog. And it's probably old data by this time that it's a C rose, but that's where that's coming from. Okay, an overview of the chassis of the lock. Not much to talk about here. Extra strength and vibration resistance from through-bolted chassis. Through bolts are removable, so here's why it's so great, but you can also make it not great. So yeah, leave the through bolts there. Aesthetics, dependability, security, affordable. I agree with all of that. This is a grade 2 lock, which means it's past 500,000 cycles. Nothing to say that this lock wouldn't go for 10 million cycles, but it's been tested to 500,000. 9 different functions. Exceptional, reliable manufacturing, fine materials. Standard door preparations. Auxiliary support springs to ensure smooth operation and long life. We demonstrated that. The lever return springs seem to be quite snappy. Quite good. Through bolt is optional. 1 3/8 to 1 3/4. If you're doing 1 3/4, leave the lock alone. It's already been set to that for you. Perfect for hotels, apartments, etc., etc. You know, reasonable moderate volume in a commercial space is perfect. It would also be considered best practice that if you had a hospital where everything is grade 1, heavy duty, across the board, that if you had a employee's closet in their office, yeah, you don't put grade 1 on that. That's unnecessary to spend the additional money for a grade 1 lock on a door that will be used twice or 4 times a day. You know, whatever, 10 times a day. Non-handed for simple installation. Key and lever lock is through bolted for additional security. Auxiliary deadlocking latch, bolt preventing manipulation. Sure, this is a deadlocking latch. It has the deadlocking tab on it. If I don't forget, when we switch back to the screen view, the camera view, I'll show you that. Keeps the latch from being lloyded. Rated up to 3-hour and handicap compliant. You can do lots of different keyways in this, and we'll talk about that. Finishes are polished brass, satin brass, oil rub bronze, satin nickel, polished chrome, satin chrome. Okay. If you want to talk more about 613, read all of this. You cannot do all the finishes and all the levers. The LG is limited, as you can see. LG, well, I think it was that curved one. Oh, no, it's the straight one. Just a straight lever. Now, what I love about Dorma, across their product catalog, well, one thing I love about Dorma is the how to order section. They really make it easy to permit you to build a part number so that you cannot forget any important component of what it is that you're trying to put together. If you recall, initially when I showed you the label on the box, that part number was longer than my arm. And that's because there's all kinds of options that can be tossed in there. And in order to define the proper lock, you need to indicate everything clearly to the factory, because the people at the factory are hardware people. You know, tech support, these are people that live and breathe hardware. Although it would be reasonable to expect that a factory would have data entry personnel entering your orders, and they don't make a living loving the nuances between half-inch min latch throw and 3/4-inch minimum latch throw required. So we've got to give them the part numbers. If you want your stuff right, we have to put it into a language that we all agree to speak for perfect translation. So that's why those part numbers get long. And this is just a grade 2. There's not a lot to do on this. So each area gives you your options. The only thing I would love is that they would stick in the lower right hand, in some part of the box, hey, page number blah, blah, blah. If you want to see your lever designs, it should be a number. We're on page 4 here. It'd be nice if they stuck a page 2 down in here so I could just easily hop to that section. And that's the point. There's your C, by the way, Rose design. That's the point of what I'm driving at here. Now, in the keying section here, which is here, there's lots of options. They will do other people's keyways, including their own, the D100. You know, you can do Arrow, these Corbin 60, these old Corbin keyways that are decades and decades old, these old Russwin key. The 981 might be from 1954, I forget. The L4 is the current Corbin. The LA is the current Sargent. You can do a Schlage F. That's pretty uncommon. These Yale 8 and the GA, these are old keyways that have been around for a long time. The Schlage C, I believe, is 1935 is when that came out. E is a less common. If you want to have a Schlage keyway that's less common, go with the E. Although if you want to even go less common than that, go with the F. And if you want to go less common, go with an EF or an FG. There are 7, I believe, in the classic Schlage series. Small format, they can give you these best keyways in small format. I would love to discuss with you at length the small format universe. If you want to talk about that, feel free to call. Here are your trim options. That would be better to put page 5. Feature solid cast handles. They just don't say if it's zinc or brass. I'm tempted to say zinc, just because it's an inexpensive lock. Then we get to our functions. You have your dummy passage. They have an exit lock, which is just no cylinder, and it's just always, it's a one-sided passage. Now what's neat about these is that you'll see these letters in bold, F109, you know, F75. If your architect tells you I need an F75 function lock, acceptable manufacturers are Schlage, Sargent, and Dorma. You can look in any of their catalogs and look for F75 and know that you're converting it equally between those manufacturers because the description will always be the same. We're doing a 53, which is an entry function. You can read all that. Basically says it's a triple function lock. And the elegance with which a description talking about function is really great when it's written very elegantly, because it will allow you to very clearly understand what exactly it is that you're getting and how it's going to function. What happens on the outside, what happens on the inside, what derivative properties that function will provide you in its other state. If you see this, it's small format. 2 equal size lobes at either end looks like small format. If it's a smaller lobe at the top, it's large format, or full size if you're Schlage. Your strike options, ANSI, T-strike, and D-strike. You can see why we'd call that a T-strike or a D-strike. Better, also known as a full lip strike, quite obviously. What options you can get in that regard. This one is probably going to give you a radiused corner. Yeah, radiused corner for the 5202. Your latch bolts. So what's neat about this is you've got 1, 2, 3, 4, 5, 2, 4, 6, 8. You've got 40 options in latch bolts. They're all not options, but, you know, because they have their functions here. Be sure to pick the right latch. What we do here, a 15252, yeah, 15252. 2 3/4 inch and an 1/8 square corner. That's it. That wraps up the product catalog. Let's take a look at the link here to the manufacturer's page. From that link, you're going to be able to pull up not only all of the Dorma products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog. Other important encyclopedic documents are here when it comes to Dorma Kaba. Service parts are here. So if you're looking for a part for your mortise lock, this might be the document to refer to. Unfortunately, they don't list every possible service part. I wish they did, but you know that's clearly an unreasonable request to make on a manufacturer. To, well, you know, they have theoretically, who knows how many possible different parts are in every item that they build. Anyway, so encyclopedic documents are kept on this page as well. Let's wrap up this video on camera. Okay, in conclusion, I'm partial to Dorma. I'm partial to Dorma for a couple of reasons. Every time that I investigate their, and I'm going to put the lock back together as I complete what I'm saying. Every time that I review one of their locks, I'm always made aware of some very interesting way in which they've reinvented the wheel. Some smarter way of doing something that's not obvious. And in fact, the primary reason I like this lock so much, they don't even tout what's probably the most important aspect of the lock to begin with. Okay. There is another reason, though. When it comes to locks, exit devices, door closers, Dorma, the name Dorma is quite synonymous with all of those different products. And when you have a line of hardware that is quite clearly, as it had been said to me a very long time ago, it's not high tech, but it's highly technical. It sure can be. You need to rely on technical support, and Dorma has an individual in technical support there who is the very exemplification of exceptional technical support. When it comes to mechanical hardware, his knowledge is exceptional at a minimum. And I discovered a couple of days ago that I had asked this poor fellow 3 times the same question, and I felt awful that I had been so selfishly using his very valuable time and energy and him as a resource when I should have just did a lot better job at respecting his time and making a note. The fact that he had politely and pleasantly answered that question each and every time, and I won't ask it again because now I've made a note, is the very reason that Dorma is a company that you ought to consider. The one thing that Dorma does, admittedly, I believe, have a reputation of lead time. They do. I mean, all manufacturers do, and for some reason it just sticks on Dorma more than others. I mean, Schlage and Yale and Von Duprin and everybody has, you know, Medico, everybody has a lead time on their product. For some reason, I think people, oh, I can't use Dorma, I don't have the lead time. Well, what are you going to use? Schlage? It's made to order as well. Where that actually has some traction is that you'll find your Yales and your Dormas, your Yales and your Schlages, more of it in stock because there's more of an installed base. Yale's a company that's literally from the mid-19th century. Schlage is about to be 100 years old. Dorma is certainly, wherever Dorma came out of decades ago from Europe, they just don't have the same penetration, I would argue, in the American market. So that's why you don't see a lot of people stocking it. So much more of it becomes a factory order, only because it's not warehoused like other manufacturers would be. But I would say that, you know, I would say this, plan ahead, because their product is awfully good. Their technical support is as good as everyone else's. And I'll tell you, more responsive isn't the right way to say it, but slower time to respond would be accurate to say. Less time to respond. Slower time. Less time to respond would be accurate. And you know what? I just need an answer on this because I need to keep going. And Dorma does a great job. Their mechanical, the gentleman there he's awesome. So I would very much recommend you review their product line and move accordingly. Dorma, their strengths are going to be, I think, everything that they sell, but in particular their door closers. Overhead concealed, surface closers, floor closers. They have an incredible complement of closers in all of those three different derivatives of a door closer, a mechanical door closer. Meaning they have applications that if you're looking to do a pull side application for a pocket door, and I mean a door hung on Harman hinges, Dorma comes to mind because I've seen that page a number of times. Other people have that, but Dorma really, you know, makes a living out of having all those applications drawn out in their catalog. It makes their door closer catalog super thick. Well, if you want all the information, it needs to be detailed. And they do a great job with that. So door closers, their 9000 series exit device, I've reviewed that. Seems like it's super awesome. They've got mortise locks, grade 1, grade 2, cylindrical, obviously, auxiliary locks. Pivots, they do a good job with pivots. I don't sell nearly enough of their pivots. I wish I did. Electric strikes, they have those as well. Electromagnetic door holders. Anyway, if you have any questions on the C500 series, in this case a 553 entry function, or any other Dorma product, please feel free to reach out to us. And thank you.